All right, we're looking at 8.1 for the online folks. The 8.0 video is posted by Dr. Webster. I highly suggest watching it. It's 15 minutes long. So, fun fact, we're learning about conic sections. Why are they called conic sections? Because they're sections of a cone. So like a circle, if you take a cone and you cut the top off it and look at it, what shape do you see? Circle. An ellipse is an oblong circle. That's if you cut it oblique. A parabola is if you cut off this edge, it makes a parabola. And a hyperbola is if you cut it like this, you end up with your two shapes. You can also get a triangle from it. But that's the fun fact, is all these functions are actually from a cone. If you'd like to learn why that is, I'm trying to think. I'm pretty sure I learned that in analytical calculus. So you can take analytical calc and learn why that is. All right. So today we're going to learn about ellipses, an ellipse, and we're going to learn about hyperbolas. Well, I stapled this in the wrong order. Oh no, this is all out of whack. Nope, we're fine. All right. Take a look at this formula. What do you notice about the A and the B between these two formulas? Like between the top and the bottom, what's the difference between them? They're switched. So A is bigger than B. And it says it right here, but I'm writing it again because that's going to be the most important concept of an ellipse is the bigger number matters. Okay? If the bigger number's under your x, your ellipse looks like that because what axis is this? The x-axis. So if the bigger number's under your x, it's bigger on the x-axis. That's an important fact number one. Okay? If the bigger number's under your y, it's bigger across the y-axis. Okay? If you know that, that's half the battle with these. Okay? Again, this test is open notes, right? I have one more thing to tell you about that when you get there. Oh, you can take notes in here. Oh, okay. All right. Now this is where things are going to get wild, but again, it's going to be helpful knowing our formulas. So we have our A and our B, right? We have an A squared and B squared. We have an A and B. The major axis length is 2A. Now, I don't like memorizing that formula. Here's what I think about. If this is my ellipse, and this length is 4, right? Because A squared was 16, so A is 4, right? And that 4 just straight up tells me that that's 4 both directions. If I know that's 4 both directions, how long is that whole thing? 2 times 4. If you are not someone who likes to think about the world in pictures, you can just use those formulas. 2 times A is how long your major is. 2 times B is how long your minor is. The one thing that is kind of wonky, I would star this formula, highlight it. That formula we're going to use every time we do this. Have we ever seen a formula like that before? Pythagorean theorem. A squared plus B squared equals C squared. They subtract over the one side. It's just Pythagorean theorem. Okay? You need to find C to find eccentricity. Why? Why do you need to find eccentricity? Eccentricity is actually really easy to find. You just C divided by A. Again, you'll have this formula sheet, right? If you want, if it helps you guys out, or even this formula sheet right here that I gave you guys has the C squared minus or equals A squared minus B squared. If you want to copy some of these formulas down on this, it's just a quick reference. That's not a bad idea. What's up? Eccentricity is like how curvy it is. Because that might be true. All right, here's why it works. if I pick any, you don't need to really, but if I pick any point and I connect my foci, what kind of triangle is it going to make on the circle? Well, actually, it's distance formula you're finding. Nah, I don't care about this. All right. Foci. Oh, this is what you do need to know, though. Has anyone taken physics? In physics, curvatures have a focus, right? A foci point. So all graphs with a curve have a foci. How do you find a foci or focus? That's a good question. Your focus is C. They didn't say this anywhere. Well, that's great. I'll go over it with this example. Your focus, so, is found with C. C is how far away from the center your focus is. So C is your focus distance from 0, we'll call it. All right. Let's do a problem. Take your time. Take a deep breath, Mr. Twiller. You can do this. So here's my question for you. First question. Is this going to be tall or wide? Wide, because the bigger number's under the x. So this graph is going to look like this. Okay? It's wide because the bigger number's under the x. Now, this is my a squared, this is my b squared, right? So I need to find 3 letters every time. If I find my a, b, and my c, I have everything I need, right? So that's it. That's going to be true for all of these. Find your a, b, and c, and that's it. Okay? So I know it looks complex. But let's break it down. What's a going to be? 10. What's b going to be? 8. Where did those come from? You just square root this, right? Square root them. Now, how do I find c? Isn't c squared equal to a squared minus b squared, right? So 100 minus 64, correct? So what's c squared equal to? 36. So what's c going to be? 6. Once you find those 3 values, can I find all that stuff they're asking for? Yeah. Once you know a, b, and c. So if a is 10, what's this distance? 10. What's this distance? 10. What's this distance? 8. And this distance? 8. So could you graph that ellipse? Or at least draw a circle and then label how far away it is? Yeah. Yeah, we can. Sorry, I'm really excited. All right. These are going to be my foci. Or 1 is a focus. How far away from the center is my focus? 6. 6. 6. Right? That's it. That'll answer every question I ever have about an ellipse. What? The what? The focus? The focus has to do with like how, if you're sending out like rays and stuff, how they bounce from one to the other. Because you're too focused. If you shoot a ray out, you'll hit the other focus. All right, so let's answer these questions now. Vertices. Your vertices, what color should vertices be? Blue, because they're sad. Your vertices are here and here. For your vertices, bless you. How far away from 0 is this? What point is that on the coordinate plane? What point is that in the coordinate plane? 10, 0. Guys, that's 0, 0.
That still doesn't matter.
That's 0, 0. So that's 10, 0. What's the other vertice? Negative 10, 0. Right? So, good, I have room over here. So my vertices are negative 10, 0 and 10, 0, right? You don't have to draw it, but you'll have to label the vertices. Like, tell me what they are. But again, vertices, where do I get them from? They're your A. It's just your A. You're square rooting the larger number, and it'll give you your vertice number. Like, I know this looks really scary, but the math behind it is really straightforward. We just have to do a lot of practice with this. You know what I mean? See a lot of examples. The good news with conic sections is this: if you can do an ellipse, hyperbolas is the same exact thing. It's just one difference, and then like, you know what I mean? It's the same process for all of them, pretty much. Okay. So covertices, what color should those be? Green. Sounds good. So covertices, who's going to make more, the manager or the co-manager? The manager. So the covertices are the smaller ones. So these are from your B. So vertices, think of it's your A. Covertices come from your B. What point is this? 0, 8. What point is this? 0, negative 8. Okay. What else do I need to know? Foci. Foci were pink. So what letter do I use for my foci? What letter do I use? My C. How far did I go over? 6. That's 6, 0. Negative 6, 0. All right. Hold on. So far, what are the only operations I've done? I've done square root and I've done subtraction, right? From that, A, B, and C. Okay? A, B, and C. So now what else do I need? Length of the major axis. What's the formula for length of the major axis from our page up before? It's just 2A, right? What was our A? Isn't it just 2A? What was my A? 10. That's 20. Could I have also looked at my graph and said 10 plus 10 is 20? Yeah. What's my minor axis length? 2 times B. What's B? 8. That's 16. And, all right, that one's silly, but we'll do it. What's my eccentricity? Now again, how eccentric are you? What's that formula? C over A? Right? So what's my C? 6. What's my A? 10. So do you see what I'm saying, though? These questions, it's crazy, and there's a long list. But do we have formulas for all this stuff? Yeah. What do we need to find to do all these? Just that. We can do that. We're just plugging and chugging and going through, okay? So I'll say it's in the history. I taught this in pre-calc a few years ago, not in AP. The first day, people hated it. By the end of it, they said this was not that bad, okay? So just trust me on this one. It's going to look really rough today. Tomorrow's going to be rough, but next week will be a lot easier to do this, okay? Trust me. Do I expect you to understand this the first time you see it? Absolutely not. Now wait, hold on. I forgot to answer one question. What's my distance between foci? What's this distance? It's 2 times c. There you go. So the math behind this section is actually really straightforward. You know what I mean? Square rooting. It does look wild though. This is the fun stuff because you can look cool at parties and be like, look at what I can do. Can you do this? And everybody's like, wow, get out of my house. All right. Absolutely not. We're filling this beast today. We got work. Because I love spike ball.
In November, they will remember. Good thing me.
All right. Hey, how do we go from a graph, or how can we go from this graph to an equation? What do we need to find? It's x squared over something plus y squared over something equals 1, right? Now, it's all you gotta do is, what's my distance from 0 to the edge of that ellipse? It's 13, right? So what do I put under my x squared? 13 squared. What's my distance on my y-axis? 6. So what do I put under my y? 6 squared. See, do you guys feel a little bit better now about this one? So my equation is x squared over 169 plus y squared over 36 is 1. Now, for fun, I'm going to go through and I'm going to list all the stuff I just did just so we can see what it's like from the graph again, to see another example. What are my vertices on this one? Vertices are your long ones. So it'd be what? 13, 0, and negative 13, 0, right? Yeah or no? Can I get that straight from the graph? Yeah. What's my coverts? These are the small. Now, these do switch spots with your x and y based on which one's longer. Okay, the longer one's the vertice. So it'd be 6 or 0, 6 and 0, negative 6. Okay, right? What else do we need to find? Let's find our foci. Uh-oh. This is the one thing we need an equation for, right? Foci, what letter do I need to find? I need to find that c. So what's our formula for c squared? A squared minus b squared? You guys have that on your sheet, right? That's 169 minus 36. So that c squared is what? 133. So c would be square root of 133, which is some decimal. But can I leave it just square root of 133 for right now? Yeah. Kinda. What's square root of 133? 11 something. So my foci would be about here and here. And that distance would be square root of 133. Because that's c. And it's always on your major axis. Your focus is on your major axis and it's c away from 0. So you find c. You can write decimal if you want. It should be about 11 point something though. It's going to ask you to round to the nearest hundredth place. So what did you get when you plugged in if you want decimal? I'm guessing 11.5-ish, 11.4.
You 11.53.
Oh, geez, I'm such an asinine fool to ever imagine it'd be anything besides that, doing square roots in my head. All right, so that's, yeah, I went about 11 and a half both ways. So my focus then would be negative 11.530, 11.530. 0. Now, once I have all those, can I answer all the other questions? Like eccentricity would be C over A. And the length of my major axis would be 26, right? Because it's just 13 and 13. Length of my minor axis would be 12, 6 plus 6. The length of my focus would be 23, right? You're just adding those numbers up. Okay? So if I gave you the graph, would you guys feel okay about that one? That one's a lot more straightforward. What's up? I haven't decided yet. All right, let's do one more. Kinda. We're gonna do this one a little bit quicker. Oh, look it! I can just do this. Sorry, that was awkward. All right, I can just do this. All right. Shiv, you guys do this one. What number is gonna go under my x squared on the, what's my A, B, and C on this? That's the big. What's A on this one gonna be? What's my longest, my biggest axis? How long is it? How long is that? 4. So A is 4. How long is this one? 2. So the thing that throws off people with conic sections is this. Your A and B, A is not always under X, and B is not always under Y, right? A is always your longest number, or your biggest number. What about C? When I do C squared equals my A squared minus B squared. So C squared equals 16 minus 4. C squared is 12. C is square root of 12. Okay. Will I be doing that in every problem you think for the next 2 weeks? Yeah, you're going to be finding C squared. It's, dude, it's Pythagorean theorem. Easy. All right. So what goes under my X? 2 squared. Under my Y is 4 squared. Y-axis, X-axis.
But why are you talking like he didn't ask me the question?
All right. So X squared over 4 plus Y squared over 16 equals 1. So are we good? Do you guys feel okay about at least finding that equation from the graph? You look at your x-axis, y-axis. Yeah. All right. Oh, I didn't write down C up here. My bad. So I'm going to just do the vertices and covertices and foci and write down those. Now for my vertices this time, they are not this way. They're this way. These are my vertices because that's my major axis, right? That's my longer side. So now, what point is that on a graph? 0, 4? At that point. Have you noticed so far there's a pattern 0, 4, so the other one's 0, -4. So that means my covertices are on my shorter axis. -2, 0. And 2, 0. Now for this beast, is my foci on my x-axis or is it on my y-axis? It's going to be on the y-axis. What's square root of 12 approximately? That'd be what? 3.445. 3 point what? Is it really? And you're 3.46. So that means I go, and a good check, if I went to graph this and I went on the wrong axis, your foci would be outside of it, right? And that'd be goofy. That's not right. This makes more sense. It should be closer.
Do I have to draw that?
What do you mean?
Take a label on the graph?
No, I do it because it helps me see it. In the I did this A squared minus B squared, 16 minus 4. Yep. And that formula is given to you, right? It's on your paper. It's also on your, it's on the bottom of this sheet. Like I said, this sheet is actually really beneficial for these because it gives you the two different sizes. No, honestly, so conic sections, like I said, are the thing that if we spent like a long time on, by the end of it, the math behind it is straightforward. It's just different. You've never seen this before in your life. I asked the kindergarten teacher to start teaching, and she said no dice. I'm like, these kids are soft. All right. Beep, 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 beep. All right. What if I give you a question like this? What if I tell you the major axis has a length of 22 and the minor has a length of 14? Could I find C with that? Mm-hmm. All you need is an A, a B to find C, right? Do you agree the major axis length, the formula is 2A? That was on that first slide, one of those first slides, right? So if I know how long the major axis is, cut it in half. That'll give me the length of A, right? So A would be 11. The minor axis, that's 2B. So B would be 7. And if you want a visual representation, this is what I would think about it as. If this length is 22 and this length is 14, you're finding half of each, right? That's all you're doing. I'm not a formula guy. So how do I find C then? C squared equals A squared minus B squared. Right? C squared equals 11 squared minus 7 squared. In real life, I wouldn't write out all these steps. 121 minus 41, 9. That's frustrating. 72. 72, right? So C is square root of 72. Now, that's what my C, right? But now what's the distance between foci? Would I just write square root of 72? Or is there a C on both sides that has square root of 72? There's one on both sides. So the final answer is you just times it by 2. Whenever you want one of those distances, it's always 2 times your A, 2 times your B, 2 times your C. Your C is square root of 72, so your distance between them is 2 times it. The distance between them is always 2 times it, because there's one on each side. Try to think, what was the other trick to this one? Or if I made you guys do that. I warned you, this was a long one. All right. We got one more ellipse. Yipers. All right, let's do it. One more. All right, find the equation. If we can find the equation, can we say everything else about it? We just need to find the A, B, and C. All right, so we got one more. The major axis is along the Y, and the minor is along the X then. So if the major is along the Y, is it tall and skinny or wide? If it's along the Y-axis. It's tall and skinny. Yeah? Because the Y-axis is the up and down one. So the major axis has a length of 20. So if this whole length is 20, what's this length right here? It's 10, right? If the whole thing is 20, half of that is 10. If this whole thing across is 12, then half of that is 6. Do I have my A and my B? Yeah. So it's going to be x squared over 6 squared, because 6 is on my x-axis, plus y squared over 10 squared That's it. That's my equation. X squared over 36, y squared over 100 equals 1. Now, how am I going to find c? A squared minus b squared equals c squared. It's 64 again. They do that a lot. But once you get the equation, we can find all the other stuff. Because what 3 letters do we need? A, B, and then C is actually going to be 8 on that one. And once I do all that, can I go back? It's the same answer as our first one we did. Like our eccentricity and all that is going to be the same. All right.
That's it.
No. No, last one of ellipses. I got to start hyperbolas. All right, if you guys want to do it tomorrow, I had a work day planned. Stop.